Recently, more and more handheld 3D scanners like this have started appearing on the market. They look a little like strange high-tech potato smashers, but inside them you will find fisheye cameras, motion sensors and SLAM technology. And surprisingly, many of these scanners are built around exactly the same sensor, the Livox MID360 LiDAR unit. In this video, I will be taking a closer look at the Share C1 scanner. I want to find out who it is made for, what kind of a point cloud data it can produce, and how freely that data can be used in other softwares. But most importantly, is the Share C1 actually a practical tool for capturing 3D Gaussian splatting models? Hello, it's me, Olli, here again. I've been trying to learn and familiarize myself with 3D scanning with so-called spatial camera for some time now. The Chinese company Share shared me one of their handheld LiDAR scanners, and I will now try to give my honest opinion on it. Share calls the C1 a spatial camera rather than simply a LiDAR scanner. The idea is that it does not capture only photographs or only measurements. It records the appearance, geometry and camera movement of an entire physical space. In other words, it is designed to photograph place in 3 dimensions. But let's take a quick look at the hardware itself. The C1 consists of a main scanner unit and a detachable battery handle, which can be recharged via USB-C cable. Together, the complete device weighs approximately 1 kilogram, and Share claims a maximum operating time of up to 3 hours. The scanner requires a smartphone and the Share Capture app to be downloaded. Without the app, the scanner won't do anything because all the scanning operations are initiated from within the app. But this is already pretty typical procedure for companion app-based device like this. The smartphone can be attached to the back of the device using a magnetic phone holder. The scanner has 2 ultra-wide-angle cameras facing in opposite directions. Each provides an extremely wide field of view, allowing the device to photograph nearly the entire surrounding environment. But the quality of these cameras is not that great. They each produce only 2.3 megapixel fisheye images, and when the distortion is corrected, the image quality suffers in the peripheral areas. This resolution and quality has been considered sufficient for coloring LiDAR point clouds and supporting the SLAM process, but it is relatively low for photogrammetry or Gaussian splatting. Because these pixels are spread over a very wide field of view, small details can appear soft and lacking in definition. But the Livox unit on top of the scanner is pretty solid. No wonder many of these scanner types have ended up using its power. Its rotating laser picks up 200,000 measurements per second, and its maximum advertised range is up to 70 meters on highly reflective surfaces. But on darker surfaces, the practical range is closer to 40 meters or less. The LiDAR scans a full 360 degrees horizontally, but its vertical field of view is approximately 59 degrees. And as I walk through the environment with the scanner, the SLAM system combines these measurements into one continuous 3-dimensional map. It is very interesting to follow the drawing of the point cloud on the smartphone screen in real time as the scan progresses. Scanning itself has been made very easy, and capturing indoors and outdoor spaces with the C1 is relatively fast. Although the device can be used for long scanning sessions, it is not very convenient because the data files grow impractically large, and holding the scanner with straight arms eventually becomes quite cumbersome. But then there is the actual post-processing phase. After scanning, the material needs to be transferred to your computer from the SD card that comes with the device. The raw data must be processed in the Share PointClouds Studio. At the moment, this software is available only for 64-bit Windows, with Windows 11 being the recommended operating system. So, although the scanner itself is controlled with an Android or iOS phone, the actual post-processing workflow requires the reasonably powerful Windows PC. PointClouds Studio has evolved considerably during the time I have been testing it. The installation package is almost 9 gigabytes, so it is not a small or lightweight application. Earlier versions had several stability problems and unfinished features, but now version 2.5 is beginning to feel like a much more mature product. Using PointClouds Studio and extracting the scanned data is actually quite straightforward. First, you create a new project and select the folder containing the raw data recorded by the scanner. Then we need to deal with these different parameters. By default, the software exports the point clouds in both colorized and uncolored versions. You can choose from several common point cloud formats, including LAS, PLY, E57 and PCD formats. The images captured by the scanner's cameras are extracted into separate folders. The software also generated distortion-corrected versions of the images, which can be also useful for further processing in other applications. At this stage, you can also choose whether you want PointClouds Studio to generate a 3D Gaussian splatting model from the same scanned data. When this option is enabled, the software presents a fairly simple set of parameters. First, you specify whether the scan was captured indoors or outdoors. Then you can select between 3 processing presets: speed, balance, and quality. These settings affect the expected quality of Gaussian splatting model, as well as the amount of processing power and memory required. When switching between these presets, the software displays estimates for both VRAM and system RAM usage. These are shown with the clear visual indicators, making it easy to see whether your computer is capable of processing the selected quality level. You can also control how many training iterations are used. It can be increased, which allows the model to train further, but this can also add several hours to the total processing time. Once all the settings has been selected, you should be ready to start the process. Except that you are not. Before PointClouds Studio allows you to use the 3D Gaussian splatting feature, you must first sign in to the Share account. At first, I found this requirement rather strange. The training is performed locally on my own computer using my own CPU, graphics card and system memory. So why should a local process feature require an online login? I asked Share directly about this, and they confirmed that the actual 3D.js processing is entirely local. According to Share, the account system is mainly used to associate voluntarily submitted software logs with the correct user and technical support case. Share cannot access or collect customer point clouds, images, or project files. Login helps Share manage account access and better understand how the software is being used. Personally, I would still prefer local processing tool to work without a mandatory online login. But at least Share has been clear about why the requirement exists. After signing in, we can finally start processing the scanned data. The first thing PointClouds Studio does is processing the images. It extracts the fisheye images from the left and right cameras into separate folders and then creates distortion-corrected versions of them. But one part of this process genuinely surprised me. PointClouds Studio also analyzes every image, automatically detects moving people, and generates separate mask images for them. It appears to use some kind of AI-based segmentation for dynamic objects and pedestrians, and does it relatively quickly. Considering that the PointClouds Studio includes special features like this, its almost 9 GB installation size begins to make a little more sense. The automatic masking feature works with varying success and helps to clean up moving objects from images that would produce artifacts and unnecessary structures in both the point cloud and the Gaussian splatting model. Once the process is running, this is usually the point where you can leave the computer to do its work. Processing can take several hours. The larger and longer your scanning session was, the more time the software will need to process all the data. And especially if you clicked on the 3D training, this phase will take multiple hours. But once the processing is finally complete, PointClouds Studio begins to reveal its true strengths. It is a powerful and surprisingly versatile point cloud processing and CAD preparation application. It includes tools for cleaning, cropping, aligning, merging, measuring, comparing, and segmenting point clouds, as well as tools for generating floor plans and section drafts for CAD workflows. The point cloud rendering itself is impressive. Depending on the size of the scan, a processed point cloud can contain tens of millions of individual points, while still remaining relatively easy to navigate. Displaying this amount of data requires the point cloud to be divided into smaller spatial sections and rendering progressively. As you move around the model, you can clearly see how loading and drawing additional sections of the point cloud are happening on the screen. The generated point clouds are extremely dense and appears to be highly accurate in terms of scale and geometry. Interestingly, the uncolored point cloud can contain even more points than the colorized version. PointClouds Studio also provides several different visualization modes for inspecting the scan. The point cloud can be displayed using its natural RGB colors, grayscale intensity values, or various gradient-based color maps. These gradients can represent properties such as elevation, distance, intensity, or point classification, making it easier to examine the geometry and identify differences that may be difficult to see in the normal colorized view. What about the Gaussian splatting result? What does the 3D model produced by PointClouds Studio actually look like? Inside the application, the Gaussian model can be displayed as its own layer alongside the point clouds. At first glance, the result looks pretty impressive. However, for some reason, viewing the Gaussian model inside PointClouds Studio feels rather sluggish. Moving around the scene and rotating the camera is not nearly as smooth or responsive as navigating the standard point clouds. For that reason, it makes more sense to take the 3D file into an application such as Supersplat, where we can inspect it more comfortably. When we open the output folder containing the generated Gaussian PLY files, we can see that PointClouds Studio has saved intermediate versions of the models at different iteration steps intervals. This is a typical precautionary measure to temporarily save the development stages, so that if the calculation fails during the process, we have a version saved for review. Other Gaussian trainers like PointClouds Studio does the same. But now let's go to the Supersplat and open the latest generated PLY file in there. The first thing we notice is that PointClouds Studio and Supersplat uses different coordinate conventions. So as a result, the model initially appears in the wrong orientation, and we need to rotate it by 90 degrees around the x-axis. Even though this reconstruction contains more than 6 million splats, it rotates and responds considerably more smoothly in Supersplat than it did inside PointClouds Studio. Overall, the Gaussians have formed into a very coherent reconstruction. As we might expect from a LiDAR-assisted scan, straight and flat surfaces are represented particularly well. Floors, walls, and other planar structures retain clear boundaries, and the Gaussians do not spread far beyond the actual geometry. This is often a problem in models reconstructed only from photograph, using a traditional structure from motion workflow. Without strong geometric information, splats can become oversized, soft, or extended beyond the edges of walls and objects. Here, the LiDAR PointClouds provides a much stronger geometric foundation. In some areas, the model is remarkably detailed, considering the limited resolution and image quality of the C1's cameras. Parts of the reconstruction look surprisingly photographic and convincing. However, the model also reveals some softness in more distant areas. Surfaces captured further away from the scanner are noticeably less detailed and less sharply defined. This is especially visible in areas where laser measurement and camera's observation were collected near the outer limits of the scanner's effective range. Of course, the model also contains some clear occlusion gaps where information is missing. These are areas that scanner could not reach or see from ground level. It is possible that some of these areas could have improved with additional training iterations. However, increasing the iteration count would also have resulted in a considerably longer processing time, and it cannot necessarily recover image details that was never captured by the cameras in the first place. Across the scene as a whole, the Gaussian model is very clean. It contains relatively few significant floating artifacts, and the main structure remains clearly defined. In my experience, the result is noticeably cleaner than what can typically be achieved from a casual scan based only on smartphone photographs. The overall reconstruction may not be the most detailed Gaussian splatting model possible, but considering the quality of the original camera images, the result is surprisingly good. But now, let's address the elephant in the room and take a look at the price. At the time of recording this video, the Share C1 is listed in Share's online store at approximately €3,570. That immediately tells us something important about the intended users. This is not a really casual consumer gadget, and it is probably not an impulse purchase for someone who simply wants to experiment with the 3D scanning at home. Share presents the C1 as a more accessible personal spatial camera, but a price of more than €3,500 still places it firmly in the professional tool category. So who is it actually for? In my opinion, the C1 makes the most sense for professionals who regularly needs to capture large physical spaces quickly and turn them into measurable digital data. This could include architects, renovation planners, construction professionals, surveyors, visualization studios and companies producing digital twins or virtual environments. For these kind of users, the main value is not simply that the scanner can create a visually attractive 3D models. The real advantage is that one relatively compact device can capture a dense and correctly scaled LiDAR point clouds. The fact that result can be exported into several standard point cloud formats and continued in other CAD visualization and reconstruction application. This workflow saves several hours of manual measuring, photographing, or repeated site visits. So, in that sense, the price may be commercially justifiable. But if your only goal is to create an occasional Gaussian splatting model, the situation is different. For a hobbyist or an independent creator interested mainly in visual 3D GS capture, €3,500 is a considerable investment, especially when the C1's cameras have reasonably low resolution and the final processing also require a reasonably powerful Windows computer. One important advantage that helps justify the price of the scanner is that PointClouds Studio does not currently require a separate paid software license. There is no additional annual subscription simply for processing your scans. But what I personally appreciate even more is the level of access Share gives the users to the captured data. I can access the original camera images, point clouds, and even data recorded by the scanner's motion sensors. So it becomes possible to develop the workflow further and experiment with the scan in other applications. For example, the image and geometric data can potentially be prepared for applications such as reality scan. And through that to other Gaussian trainer applications such as Lichtfeld Studio or PostShot. Of course, these alternative workflows are not necessarily simple or officially automated. They require technical knowledge, experimentation, and sometimes custom scripts, so this openness will not be equally valuable to every user. But for developers, technical artists, researchers, and anyone who wants more control over the captured material, it creates possibilities that would not exist if the entire process were locked inside the manufacturer's own ecosystem. If this type of a scanner has caught your interest, I would also recommend taking a look at Share's other model, the S20. It can be considered as the C1's bigger brother. The S20 is equipped with two considerably better 1-inch cameras, and it also includes an integrated RTK receiver as standard. This makes it better suited for accurate georeferencing, large-scale mapping, and professional surveying work. However, RTK positioning is not completely unavailable on the smaller C1. Share offers a separate RTK module for C1, allowing the scanner to be expanded when more accurate global positioning and georeferencing scan data are required. Okay then, I think that gives us a fairly complete picture of what the Share C1 scanner is and what it is designed to do. It probably goes without saying that this is not a scanner intended for capturing individual objects. Its real purpose is to document larger spaces, buildings, construction sites, and outdoor environments. Although the C1 is capable of producing 3D Gaussian splatting models, in my opinion, Gaussian splatting is not its primary focus. At its core, the C1 is mobile LiDAR scanner designed to produce dense, accurately scaled point clouds for measurement, documentation, mapping and designing workflows. The 3D GS feature is useful and at the end surprisingly capable addition, but it should be seen as one possible output of the scanning process rather than the main reason this device exists. You can find all the relevant links in the video description, and if you have used the Share C1 yourself, I would be very interested to hear about your experiences, so please leave the comment below. If you found this video useful, please give it a like and subscribe to my channel. I'll see you again next time. Thanks for watching.